back to the program, everybody, and we're moving into part 4 of episode 6. This part is all about keys. We're going to have a look at what those are, why we've got them, and how to actually create those. So let's move on in SQL Server Management Studio. And before we begin, first things first, of course, we need to change that database. So let's go ahead and do that. Now, before we move on to creating keys, I thought it would be best to explain to you why we've got them. And the best way to go about doing that is to bring up the database diagram that we created right at the beginning, diagram 0. And don't worry if you haven't got this diagram anymore. Simply just right click on New Database Diagram and select the relevant tables and then hit OK. I'll show you when I open the diagram. Just double click that. We're after this the customers table, the orders table and the order lines table. Right then, looking at these three tables here, you can see there seems to be some sort of link between the two. Now, as you can see, if I hover over the with the mouse, it says relationship FK, and that's short for foreign key. So that's effectively a foreign key relationship. And you'll see on the customer ID column here, it's got a little key there. So that says that that column there has been designated as the primary key. And if you remember, when we looked at the customers table, every customer had a unique customer ID, and there's no null values as well. So we could assign a primary key to the customer ID column there, as designated by the key here. However, as we move on to the orders table, we know that we link to the customer ID, but the customer ID column in the orders table, we can have many entries of the same customer ID. In other words, one customer can place many orders. And that's why on this side, if you see it's got the 8 on its side, that's the symbol for infinity. So one customer ID can link to many customer IDs here, because of course one customer can place hundreds or thousands or even millions of orders. So it's effectively a one-to-many relationship there. Now this isn't some sort of physical link between the two tables, so if this was removed then the database will break. All this does is simply reinforce what's known as referential integrity. Now, we know that when we were doing our queries, we linked the customer ID to the customer ID in the orders table from the customers table if we wanted to join them together to bring the relevant information in, say the customer's name and then an order ID. So we used the inner join. Now, when they were creating this database, they went through the trouble of creating it in a really good way. So we could assume that that customer ID column there joins to that one there. There's no physical link set up to join the two, but we made the assumption, which worked out correct, that we could join on those two columns. Obviously, we could have joined customer ID on any one of these columns here if we chose to, but we would have probably have ended up with some very strange results if we ended up with any results at all. So we simply made the assumption that customer ID links to customer ID there, and we're happy with that. And that is the relational part of the relational database, is that they've pretty much, when they've designed this database, set it to act in that manner. Now these links here are all about referential integrity, and what that's all about is that this says that if you have an order, if you want to place an order, whether it comes through on the system or however, you first need to have a customer ID. You can't place an order without a customer ID. Otherwise, where is the warehouse manager going to ship the order off to? He wouldn't have a clue. So we need to make sure that we have a customer in our customers table first of all. Once we have that customer, then we can start placing orders against that customer within the orders table. And it's the same if we look at the link between the orders table and the orders lines table. We can't have any order lines unless we have an order ID, and all our order IDs are unique, hence the little key there for the primary key, and it links to the order lines. So we can have one order ID in there, but one order ID in the orders lines table can have multiple order line IDs. Basically, one customer could create an order that has hundreds of individual order lines. So he buys hundreds of different items in one single order. So we have uniqueness on the order ID here. However, as we've seen, we can have multiple of the same order IDs in the order lines table as it then moves down to the order line ID. So once again, we've got our key there going to the infinity symbol as it joins to the order lines. As you can see, if you hover above, they've given us a pretty good description. Foreign key, sales orders, customer ID, joins on the sales customers table, and it shows us the link between the customer sales and the orders sales. So it's quite descriptive what they've put there, and it tells us which column they are linking on, which column they are pushing referential integrity on. So that's the customer ID between the two tables. Hovering on this, there we go, it says the order ID after the sales order lines order ID. So we know that it's joining on the order ID there. It's forcing referential integrity. So what would happen if we tried to place an order in the orders table without actually giving it a customer ID, or even putting in a customer ID that doesn't exist in the customers table? Well, the insert will fail. It'll just say, we've got this referential integrity here, these key relationships, and there's no customer with that customer ID, so we can't put the data into the orders table. And it's the same with order lines. If you try to insert data into the order lines table without a valid order ID that exists in the orders table, the insert will simply fail. Now you may notice something weird going on with these joins up here. It looks like the table's sort of joining onto itself there. That is purely a self-referencing, referential integrity. Basically, if you hover over it, you can see the bill to customer ID is the column being mentioned there. So all this is saying pretty much is that in order to bill to a specific customer ID, we still need to have that customer ID in the table first. So let's have a look at the table. To explain that very quickly, let's look at the customer table. We'll select the top 1000 rows. So as you can see here, we have a customer ID of 1, and we have a bill to customer ID of 1 as well. So that's the head office, and all the subsidiary branches fall under that. There's loads of them there, as you can see, hundreds of different branches going all the way down, but they all bill to customer ID 1, the head office. So we need to make sure that before we can bill to a specific customer ID, that customer ID already exists, and customer ID 1 exists, so we can bill to them quite easily. And of course, if we try to assign a bill to customer ID that doesn't exist in its own table, then of course the insert will fail. But that's pretty much it for an overview of what the keys actually look like in the database, and it's all about enforcing referential integrity, and we'll have a look at that when we go through the lesson in a little bit more detail. Let's close that one down. We'll save it. So, how do we then go about creating our keys, both our primary keys and our foreign keys? So as we remember, our primary key goes on the table where there is some sort of uniqueness in that column. And looking at the customer table, the sales customer table, we saw that it was the customer ID that was unique, so we could put a primary key on that. Now, the guys who built the Wide World Importers database has done such a fantastic job of ensuring that all the keys are added to the database. We're going to have to create a table on our own to then start putting primary keys in. So we're just going to create a table on the sales schema, and we're going to call it customer name. And all we're going to put in this table is we're going to create a customer ID column and a customer name column. Customer ID is integer. We're going to write the words primary key over here, and that will make sure that when this table is created, this column here becomes the primary key column. Notice that there is no data in it once we've created it, but as we insert data into it, it will build the primary key as we go. And of course, we cannot have nulls in a primary key column, so whether you specify not null or you leave it out doesn't really matter. It will default to not null when you place the primary key in there. Customer name, we'll just put an varchar or even a varchar. Your choice to put that in, and we'll make that not null as well. So let's have a go. Let's create the table. There we go. I'll create our tables in there now. Let's just right click and refresh on the Object Explorer. So we've got our customer table in there. And we've got our columns. There. And you see it says primary key there. PK for primary key. Now it also has a little folder here for keys. Open up, and there you can see the information on the key that we've just created. Now the thing that you can see is it has a default as the name of the key, and it has quite a few random characters afterwards to give it some sort of unique identification. Obviously primary key on the customer table, and then some sort of ID. Close that down. Now what if we wanted to instead actually name the primary key itself? Well, let's drop the table quickly, and that'll drop it from the database, which also removes any keys attached to it. Control Z back to create, and we'll remove this column here. Now we need to specify that it's not null, otherwise it would automatically default to null, and this next bit of code will fail to actually apply the primary key. So we'll specify not null there. Create the table, execute that. Let's refresh the tables here. There we go. And we can then alter the table, specifying which table we want to alter, and we can then add a constraint. In this case, we're going to name our primary key as PK underscore sales underscore customer ID, and we're going to put the keyword primary key afterwards, so that designates at as a primary key. So that's the name, what we're going to call it. That's the type of constraint, primary key. And then we open and close the brackets, and in the middle of that is the customer ID. So we're specifying the column that we're going to be applying that primary key onto. Similar thing as we did here. So let's go ahead and run that. There we go. Quick refresh again just to make sure we're up to date. And there's our table in there, customer name. As you can see, our primary key is named as we wanted it to be there, which is fantastic. Now let's have a look at creating the foreign key relationship. So this is the relationship on the other end of the referential integrity link between the two tables. So this is going to be where we have our customer name with the unique primary key, and then we're going to have customer delivery details as our second table, which we're going to relate to this primary key. Simply create the table, I've called it this, and then I've put in all the various bits and pieces, all the different columns. Don't worry about the n varchar and varchar. We'll keep them all as varchar for now, because we're not using any foreign characters from different languages, so we're happy to keep them as varchar in there. Now obviously we need something to link the primary key to, so we're going to have our customer ID as well, and we're just simply going to create the table as is. So let's execute that, and then we need to create the foreign key constraint itself on that table. So we'll start off in the same way as the primary key, where we alter the table. We then need to add constraint, and we're going to give our constraint a name, as you can see. Then we need to specify foreign key as opposed to primary key up here, and then we simply put the column that we want to put the foreign key on, and in this case it's the customer ID, because we're going to join it to the customer ID in there. Now the main difference, of course, is we need to tell the foreign key what primary key it references, or what column in what table. So we use the keyword references, and we put the schema with the table name, which is the new one we created up here, and it's going to be linking to the customer ID column. Don't forget those brackets there. So we've created a primary key on this unique column here, and we've then created a foreign key on this table here, as you can see, and it's going to link back, it's going to reference that customer ID from the original table. Let's go ahead and execute that. Fantastic stuff. So once again, let's see what we've done. We're going to refresh that, and it's sales, customer delivery details. Here we go, keys. As you can see, FK sales, customer delivery details. We can also then right click and hit modify, and it'll show us a little bit of information on the foreign key relationship itself. Here's the name, etc., etc. A little bit of detail, not too much going on there, but that's just some information for you there. So we've created our primary key on our new table that we've created. We then created our foreign key on our second table and linked it back to our primary key on our first table. Fantastic stuff. So we're going to try the referential integrity. We're going to give it a go and see if our keys actually work. So we need some data to test it on. So all we're going to do is insert into our new table the customer ID and customer name from sales customers. Now note, we're only inserting the top 10 rows. So if we grab that, as you can see, it's already sorted by customer ID without us having to order it. So all we're grabbing is the top 10 customers there. So let's insert those into our new table. And of course, for our customer delivery tables, we're going to insert the top 10 as well. So if we go on our sales customers as well, we're going to use the same exact table, sales customers, to put in the top 10 rows, but as you can see, we're using slightly different information. So let's insert those rows there. There you go. So in our primary key table, we can see we've got 10 customers with a customer name. In our second table, the one that we're going to build a foreign key on, we've also got our 10 customer IDs, and the data went in just fine without any issues. Top 10, top 10. So we're happy with that. Now, what happens if we try to insert a record where the customer ID is 11? So we're going to put another record in here. Bear in mind, we've only got 10 records in here, customer ID of 1 all the way to 10, so there is no record with a customer ID of 11. So that record does not exist in this table. So what happens if we try to add it in to our table with the foreign key? There you go. There's your conflict with the foreign key constraint. And it will not insert the row in there because there is no record in our primary key table that has a customer ID of 11. So we can't insert that record into our second table because our foreign key simply won't allow it. And that's pretty much that for your primary keys and your foreign keys. Remember, all they are is there to enforce referential integrity. So you can't place an order without first having a customer to place the order against, and so on throughout the entire database. Right then, let's give it a go and see if we can create some more given this scenario here. So the sales manager is after a process by which he can extract orders for our corporate customers only. Now, as you've decided to implement the new key relationship skills you've just learned, you've decided to place the data in a couple of new tables. So all we need to do then to build those tables and put in a key relationship is to follow these 3 steps here. So first of all, we need to create these tables using these columns from this table here, adding in a primary key to that column there. Then we need to insert all the corporate customers into this new table from the customers table, pretty much similar to what we did above. Now the customer types can be found in this customer categories table, linking on the customer category ID. So once you've created your table, you need to create a little bit of code inserting into it, but remember, you might have to do a join on your customer table and your customer categories table to make sure you're bringing in the right data in order to insert into the first table. Second of all, we're going to create our second table, which is the corporate orders, using the customer ID, order ID and order date field from our sales orders table. Now, simply alter the table, set the customer ID field as a foreign key, linking it to the primary key in the new corporate customers table. So that's when things get interesting, and you just need to follow the directions in this little block of code here in order to create that foreign key. And then what we need to do is try and insert every order from the sales orders table into the corporate orders table to check if the relationship works. If it fails, we know that the referential integrity is good to go. If we've checked that and we're happy that that works, we then need to successfully insert all the corporate orders from sales orders into the new corporate orders table. So once again, a little bit of joining to make sure we select the right orders during our insert into. So simply follow those few steps, and remember, build up your select queries first before you insert them into any of these tables. Now, if you want to give that a go, please pause the video and then we'll crack on with the answer from my perspective. Right then, let's tackle step one first of all. So we need to create a table. So let's crack on with that. And we're simply going to use the same schema that we usually use. Sales, corporate customers. Right. So now we need a few columns. We're after the customer ID and we're after the customer name columns. In fact, what I'm going to do is simply grab the code from up here, adding in a primary key to the customer ID column. So let's just put a quick primary key in there. So that's our table pretty much. We've got the customer ID and the customer name. So let's use that. And we need to now put some data into our table. So we've got the data in the sales customers table. Once again, I'm going to be quite sneaky and grab the code that I already used up top, and we just need to change the table here. Oh, I didn't grab the data. So it's not the top 10. We are actually wanting to only bring across the corporate customers. So let's have a look at this table here, sales customers categories. As you can see, we've got a category name in there and we have corporate there. So we know that we can join to this table customers, and then join categories A, customer category ID equals customer category ID. Fantastic stuff. So we then need to put a filter either on the inner join or the where clause, doesn't matter where you put it in because of our inner join. Customer category name equals, as we're putting a string, copy that and paste it in there, equals corporate. So that makes sure that we've only got corporate customers. We can double check our work. If we really want to. If we want to make doubly sure, and before we insert anything, let's test our code. And there you go. These are all corporate customers. So we're happy with our code there. So then let's go and insert those rows. Let's get rid of those because we only need these two columns. So make sure we hit the right table and we execute. So now if we check our table, we can see we've got all our corporate customer IDs. Now you also notice that the customer ID is sorted in ascending order, so from the lowest to the highest, and the primary key is a specific type of index that does all that automatically, and more on indexes in the next video, and I'll explain this in a little bit more detail. But we've now got the table we want in our corporate customers table. Brilliant stuff. So that's step one done and dusted, and we can move on to step two. So we need to create a corporate orders table. So let's go ahead and do that. Corporate orders. Alrighty, so what columns do we need from there? Customer ID, order date field from the sales orders table. Let's bring that one in. Customer ID, we've got it in there. Let's remove that primary key. Order ID and the order date field. Brilliant stuff. Now we're not quite sure what the exact data types are. We know that our ID columns are integers, but our date could be a date or it could be a date time. So we're going to have a look at our sales orders table because that's what we're going to bring the data in from, and we're going to right click and hit design. Scroll down the list. Order date is simply a date, data type. So and we know that we can't have an order without an order date. And we'll then alter it once we've created it, and we'll bring in our foreign key. Alrighty, let's create that table then. Corporate orders, corporate customers. We've got our three columns, and we'll execute that. Let's just grab the code from up top. Alter table, and let's make sure we alter the right table from there. And we're simply going to rename it as such. Foreign key on the customer ID, references, and we're going to reference this table up here again on the customer ID table, because that's what we're going to link our foreign key to. So we've got the right tables, we've got our constraint in there, we're doing it on the customer ID just like we did previously, customer ID, and we're linking it to that table there. So fantastic. Let's see if that'll run. Execute, and we've got our foreign key. So let's have a quick look at our tables. Corporate customers, corporate orders. Then we've got our primary key as a random name, and corporate orders, we've got our foreign key called corporate orders. Brilliant stuff. So we've set up our relationship. Now in step 3 we need to test that it works. So we're going to try and insert every single record into the corporate orders table from our sales orders. So what do we need to put in corporate orders? We need these columns here. Sales orders, let's have a look at that. Fantastic, works fine. Let's see if we insert into our sales corporate orders. Let's see if that works. And there you go. It's broken our foreign key constraint because obviously the entire table, sales orders, contains a multitude of different categories, customer categories. So we know that our referent integrity, our relationship works. So now we need to successfully insert all the corporate orders from sales orders into the new table. So all we need to do in there is, well, this is a slightly more complex select statement where we need to inner join on sales customers and we're simply reusing the code that we've got above. So we've got our order ID, customer ID, oops, a bit too quick for my own good, and we know that we can link the customer ID to the orders table using our customer ID, and we need to make sure that it's just corporate customers there. So it's confused which customer ID to use, so we're going to put everything from the orders table. Let's do our select statement first, just to make sure it's working. We've got data. There you go. Now let's insert that data into sales corporate orders. And there you go. It worked just fine, telling you how many rows were actually inserted. Brilliant stuff. So that is a very quick walkthrough of the keys. We've got the primary keys, and we then have our foreign keys, which then relate to those primary keys. A few things to consider when you start building them and creating them, and obviously a bit of coding to get your head around there. Now normally these keys are set up when a database is created by whichever developers and database administrators, etc., create the database, so you probably won't be creating many in your time. However, you need to know what keys are and what they're all about. So if you are inserting data in tables, etc., and you get a foreign key relationship error, you know exactly what's going on. And that's it, everyone, for part 4, all about keys. We're going to have a look at indexes next. So join me then in part 5, and we will continue with the SQL magic. Until then, everyone, I wish you all a fantastic day.